In this video, we're going to solve two composite shape questions and take a look at some flashcards to review. For number 4 on page 107, it's a question about pulleys. Each of these pulleys has a diameter of 15 meters. So the diameter all the way across for both of these pulleys is 15 meters. I'm going to label that. D is equal to 15 meters. D is equal to 15 meters. The question asks, what length of belt will be needed to encircle the pulleys? Answer in meters. So right away we can see from the question they want the answer in meters, not in meters squared. So that right away helps us to understand what's going on here. And if we look at drawing this and using a little bit of color, we can see that we want the measurement of the belt going along straight, going around this half circle, going down the other straight, and then going around this half circle. So this would be used in so many things, but the first thing that comes to my mind is something like a fan belt in your car. So we want to know the distance all the way around. We know that the length from here to here is 60 meters, and therefore it means on the other side it must be identical. It's also 60 meters. What we have for the belt going along is it's going along a half circle here and a half circle over here. So 2 half circles makes a full circle. So we can solve for the circumference of a full circle instead of solving for 2 half circles. So let's get our formula, let's get our plan kind of going. So if we know we have to solve for 2 half circles, which is a full circle, and we're looking for really calculating the perimeter here of this belt, then we're going to take our circumference formula for a circle, pi times the diameter. We don't have a rectangle here because we just have 2 long pieces. So we are going to add the 2 pieces, 60 meters plus another 60 meters. You could also just double the 60 mentally and write 120, but I'm going to write them both separately, so I want to account for both of those sides. So we're going to use rounded pi, 3.14, times the diameter. The diameter was provided, 15 meters. So we're going to solve that, and then we're going to add to the 60 and the 60, which is 120 meters. When we multiply 3.14 times 15, we get 47.1 meters. We add that to the 120 meters. And so the total length of the belt, so we can say that the length, which is our perimeter, is equal to 167.1 meters. And I believe the exercise asked us to round to the whole number. So we're just going to round to 167 meters. Question 5 is similar in how we solve the perimeter. So here's our ice rink. We need to find the perimeter and also the area of this rink. If we look at our perimeter, we are going to do just like we did with the pulley question. We're going to see that the diameter of this half circle is 28 meters, and because I have 2 half circles, I really have 1 full circle. So the perimeter is going to be pi times the diameter. That will give me both of those semicircles. And then I'm going to add the 2 lengths. I have 80 meters and 80 meters. Both sides are the same. So I'm going to be adding both of those 80 meter lengths on. So this will be 3.14 times 28 added to 160 meters. So the total perimeter, I'll just write it underneath here. You're going to get that 160 plus 87.92 And then we'll come to an answer with a decimal 247.92. So I'm going to round that to the whole number as the exercise stated. So this will be 248 meters, the distance all the way around that ice rink. For the area, we're going to see this now. This is a composite figure. So that means it's a couple shapes put together. So what we have is a rectangle first in the center, and then we have two half circles. But again, two half circles equals one full circle. So I'm just going to label this one as 2. So we are going to take the area of the rectangle and we are going to add that to the area of a full circle. What we need to do for our area of our rectangle is use length times width formula. And for the area of the circle, we need pi r squared. The question has provided us with a diameter, not the radius. So we need to calculate the radius by dividing the diameter in half. So we are going to take 28 divided by 2, which is 14. So the radius is going to be 14 meters. So now that we know all of our numbers, we can go ahead and start to get our length times our width. So 80 is our length, and our width is the diameter that they provided. So the width is also the diameter. So 80 meters times 28 meters. That will give us the area of the rectangle. And then we'll use rounded pi, 3.14, times the radius, which is 14, and that radius is squared. When we go about getting our numbers, we are going to have 2,240 square meters plus 615.44 square meters. We add those values up and we round them, and these will round down, so that 0.44 will just go away. So we'll end up with a final answer of 2,855 square meters as the total area of this composite figure. Remember, for all shapes, whether it's just a single shape like a rectangle or a composite shape made up of a few different shapes put together, or a shape inside of a shape, using the formulas and writing them down before you begin and thinking about your plan of attack will really help you be successful in this section. If you'd like to do a little bit of quick flashcard review to test yourself, I'm going to go through the slides one by one. There are 10 flashcards here. Number 1, what is this called? This is a line. Remember, this is line AB or line BA. So what we have here are 2 points on a line, but this line will go in both directions forever. Number 2, what is this called where we have 2 of these lines crossing at a 90 degree? These are perpendicular lines. When lines cross or intersect at 90 degrees, they are called perpendicular. If you want to write that symbol between 2 lines, you would use this. So for example, if we have line AB perpendicular to line CD, that's how we would show that expression. Number 3, what is it called when angles added together equal 90 degrees? These are complementary angles. Remember complementary as being corner, and that will help you to remember the 90 degrees. Number 4, you're going to classify this triangle 2 different ways. One way based on its angles, and one way based on its side or sides. This is an isosceles acute triangle or acute isosceles. It doesn't matter which one you say first. Because all three angles are below 90 degrees, that makes it an acute triangle. And because two of the sides and therefore two of the angles are identical, that makes it isosceles. Number 5. What is this called? Right here where I'm pointing at that letter O. And then how would you name this angle if you had to write it down? There are two ways to name this angle. This point O is called the vertex, and if we were to name this angle, we could either name it as NOM, or we can name it the other way, MON. The vertex is always the center letter. Number 6. What are these two angles called when they are side by side? What do they equal when they are added together? So these angles here, what are they called when they're side by side? And together, what do they form in terms of an angle? So these are side by side or adjacent angles, and these are supplementary angles. They add to 180 degrees. What are these shapes called? They're all the same in terms of their classification, but they all look a little bit different. These are all examples of trapezoids. Remember that a trapezoid, by definition, is an irregular shape, but it has two parallel sides. Remember, look for the parallel sides. The parallel sides will never cross, and those are your bases of your trapezoid. What kind of angle is this one? This is an obtuse angle. If we use that 90 degrees as our frame of reference, we can see that this angle is greater than 90, and that is what makes it obtuse. What is this called? So we have a circle here, and from the center point to the outer rim, what part of the circle is that? That is your radius. Remember that the radius goes from the center to the outer rim, and that two of them create your diameter. What is this called? Where we have a line that cuts through the center of the circle from rim to rim, going directly through the center point. This is your diameter. Remember that for questions for area of a circle, if you are provided with the diameter, you will need to cut it in half, divide by 2 to get the radius. So just a reminder that the assignment is due today and that the unit exam is on Wednesday. And good luck. If you've already done your assignment, that's awesome. Even if you're watching this video after it's been handed in. And best wishes on your Module 4 exam.